In the previous video, we created the basic infrastructure, the VPC. We talked about the ECR. This video, we are going to do some more basic infrastructure. So in this case, let us go to the EC2. So the first thing that we are going to do is to create some security groups. So the first security group is going to be associated with the internal load balancer. And the second security group is going to be associated with an external load balancer. So first, let's create a security group for the internal load balancer. So I will give internal application load balancer security group. I will copy paste the same in the description. Instead of the default VPC, we will select the custom VPC that we have created. So this particular security group is going to allow any HTTP traffic emanating from the VPC, that is 192.168.0.0/16. So this means that the security group is going to be associated with an internal load balancer. That internal load balancer will allow any traffic coming to the port 80 from inside the VPC, because we had created the VPC with this particular network. That's all there is to it. Let us create the security group. And that's it. So we have created the internal load balancer security group. So let me give a name to this. Save it. We are going to create one more security group for the external load balancer. So let us give an external application load balancer security group. Let me copy paste this in the description too. So again, this will be for our custom VPC. And then we are going to have an inbound rule. Again, the same HTTP from, so this, it is coming from anywhere. So that means anywhere outside the internet. If they hit the port 80, this external load balancer, which is going to be associated with the the security group, which is going to be associated with an external load balancer, will allow traffic at port 80. Let us create the security group. So we have effectively created two security groups as we have done previously. Let us just copy and give the name also here. So one internal load security group that is going to be associated with an internal load balancer, which will allow port traffic from the VPC, and an external load balancer, which is going to be associated with the external application load balancer, which will allow traffic at port 80 from the internet. Now it is time to create the load balancers itself. So clicking on the load balancer, again, still we didn't go anywhere. All these things are available when you go to the EC2. Let us create a load balancer. So there are different types of load balancers. We are going to go with an application load balancer because it works at the HTTP level. And so let us go ahead and create it. So this is going to be, I will give it as application load balancer and give a private as the name. And of course, there are two options. This is going to be internal facing, and then which is the VPC. This should be associated to our custom VPC. Because we are creating an internal load balancer, it has to be associated with the private subnets only. So two availability zones, you can see here. If I just change it to public, Amazon will give us a warning that your internal load balancer must have a private subnet. So we need to have private subnets here. That's what I have selected here. And then the security group is going to be our internal application load balancer security group. Do you remember how do we create this? This will allow traffic at port 80 from the VPC. And then the listener, That means it will listen at port 80. And to which target groups? The target group means the instances that is going to be run in the EC2 instance. But here there is a catch. We are going to create a target group, but it won't be the target group that we be using. So what I'm going to give, I will give a dummy private as the target group because it is going to be, and I will leave everything as blank. So I think I have to create, yeah. So the target group, why I'm giving this as dummy, because when we go to the ECS and create the service there, at that time, a target group will be provisioned there. That is the actual target group. But because Amazon doesn't allow us to create a load balancer without a target group, we are forced to create a dummy target group like so. Again, we won't be using this target group. We will delete it later, but we are doing it anyway. So because we are not going to use this, I will give everything as default and click on next and then create the target group. So now that I had created the dummy private as the target group, I will refresh it and select the dummy private target group. That's all we need to do. So we have created an internal load balancer with a security group that allows traffic at port 80 in this particular VPC, and it will point to or forward the traffic to each of these private subnets. And we have associated a dummy target group for listening. That's all for creating an internal load balancer. So of course it will take some time for the state to change from provisioning, but we don't need to wait for that. Let it take its own time. So what we'll be doing from our application, we will be using this particular name to hit this particular load balancer so that it forwards the traffic to the corresponding microservice. Next, we are going to create yet another load balancer. Again, the application load balancer. We are going to give this load balancer name. I actually, let me give, so this is ALB private. So let us give this as ALB public. So application load balancer, this is going to be public facing. And so here instead of internal, we will be using the internet facing. And again, we are going to associate with our custom VPC. So if you remember previously, when we created the internal facing load balancer, we had to choose the public subnets, private subnets. But in this case, because it is internet facing, we have to choose the public subnets. So I will choose both the public subnets that I have already created. And then again, so what exactly is the security group that is going to be associated with? We have already created an external ALB load balancer, which allows traffic at port 80. Then which points to, so let me close this. So which points to the which actually is associated with this particular load balancer. And then again, we are forced to create a dummy target group. So let me create a dummy target group again. And this is going to be dummy public. As again, as I told you, we won't be using this target group. The target group will be created when we create the ECS service. You will come to see that. And then I will keep everything as optional or whatever the default. I will just click next and create the target group. So of course you can see there are two target groups, each for, this is for the private load balancer, and we are yet to associate this public load balancer. So let us refresh it, get that public load balancer. Our job is done. And then the summary, we are creating an internet facing load balancer. We have associated a security group with that load balancer that allows traffic at port 80, and it will be forwarding to that particular traffic to each of these subnets, whatever the application running. In our case, Docker containers running in these subnets. And then let's create the load balancer. We have created two load balancers. So we have created, so the private load balancer is already active. the public load balancer is getting provisioned. So we have effectively, so what are the things that we did in this schedule? We created two security groups, one for the internal load balancer and one for the external load balancer. Then we created two load balancers. One is the private or the internal load balancer and an external load balancer. And for each of these load balancers, we created some dummy target groups for the same. Our job of creating load balancers is done. Again, we will come back and tweak these load balancers a little so that the whole application works correctly. So the next thing that we are going to do, we are going to go to the ECS, create the tasks, and then see how exactly we are going to use these load balancers for communication.